Hi physicists, what's the crack? So today what we're doing is we're going to figure out if I have these cells set up in these different formations, how do I figure out what the total EMF and the total internal resistance is of each one? Okay, so first thing I would do is I would look at the batteries and I would write in what the EMFs are. So if I look at my cells, there's 1.5, 1.5, 1.5, and if I was an electron in this one, the electron has to go through every single cell. So because it has to go through every single cell, it will gain 1.5 joules of energy as it passes through each one. So because it gains 1.5 joules of energy each time, I know that the total EMF of this setup is going to be 3 times 1.5. 3 times 1.5 is 4.5 volts. Okay. Next one then is I want to figure out what the total internal resistance is. So I can see my little internal resistors here. And again, I'm just going to write on the numbers on my picture. So I have 0.6 here, 0.6 here, and 0.6 here. Okay. So again, I think about an electron. An electron has to go through all 3 of them. So because it has to go through all 3 of them, it's going to feel a resistance trying to push them back from every single one. So again, resistors in series, I know we add them together. So the total internal resistance is going to be 3 times R. So what's it going to be is 3 times 0.6, which is going to be 1.8 ohms. Okay, so the next one then is, again, I look at my electron. So I'm going to write on the potential difference of each cell. So I see 1.5, 1.5, and 1.5. Okay. If I was an electron, I have to go through every single cell in order to get out, okay, because they're all in series. What you hopefully noticed here is this cell is connected opposite to this cell. So here what I have is a positive and a negative, and here what I have is beside a negative and a positive. So they put in opposite directions. So what that kind of means is the electron gained 1.5 joules, but then you've got 1.5 joules trying to push it in the opposite direction. So I get a positive 1.5, take away a 1.5, so technically it comes out with 0 joules. So then the only thing it goes through now is the 1.5, so the total EMF there is just going to be 1.5 volts. Okay, the next thing then is I want to figure out what that internal resistance is. So think about my electron again. It had to go through every single internal resistance. So again, I know it went through 0.6, it went through 0.6, and it went through 0.6. So because they're in series, we add them together. So again, I've got 3 times 0.6, same math as before, to give me 1.8 ohms. Okay, and for our last one then, well again, we go think about our cells. So each cell, again, has got an EMF, an electromotive force, of 1.5 volts. So I pop in my 1.5s. Okay. So again, I think about an electron. So if an electron starts here, I know it has to go through that first cell. So it's going to gain 1.5 joules of energy. If I was an electron right here, I have a choice. Either it chooses to go through the top branch or it goes through the bottom branch. But either way, it will only go through one of these cells. So let's just say it chooses to go through the top branch. So it's going to gain another 1.5 joules of energy. So then what it comes out with, the total EMF, is going to be 2 times 1.5, which is 3 volts. Okay. You think about the opposite way. Let's say the electron went through this one because it has to. And let's say it went through the bottom route. Again, it gained 1.5 here. It gained 1.5 here. So it still comes out with 3. Okay, internal resistance is a bit different. So again, if I think about my rules for resistance, if I have 2 resistors in parallel, I know the math is 1 over RT equals 1 over R1 plus 1 over R2. Okay, so that's my rule for resistors in parallel. So what I have is 1 divided by 0.6 plus 1 divided by 0.6, which is 2 divided by 0.6, and that equals 1 over RT. So in order to find RT, I have to flip that fraction. So RT is going to be equal to 0.6 divided by 2, which is 0.3. Okay, so what I figured out, for the 2 resistors in parallel, the total resistance is 0.3. Okay, so what I can imagine then is that I just have one resistor here with total resistance of 0.3. Okay, so if I look at my electron now, it has to go through this resistor, which is 0.6, and through this resistor, which is 0.3. In series, we add them, so the total resistance is 0.9 ohms.